right, let's look at a test. Ready? And once again, I don't mind this being on the paper, but that's the back. The back is going to have all of this stuff on it. The short answer questions and the Lewis structures. The front, okay, I can read that off to you right now. First section, 7 questions. These are a gift. Classify the following as A, nonpolar, B, polar, or C, ionic. What will you have to do if I give you 2 elements and ask you if it's going to be a polar, nonpolar, ionic? Subtract. Yeah, if you can subtract 2 numbers, and don't ask me for a calculator tomorrow. If you don't bring a calculator tomorrow, use your head. That's the hardest thing you're going to have to do tomorrow on a calculator. Now, next 7 questions. Multiple choice. Now these are going to come. I'll tell you, at the end of the day, the back side, I don't expect to see a whole heck of a lot of red marks on the back of this test. The front is where most of the mistakes, most of the points off will be. And those 7 questions in the multiple choice are going to come from your notes. There aren't many notes. And I think they kind of get into you're complacent because of that. In biology, you guys had reams of notes. Granted, you didn't have to always write them. Whoever you had, for most of you, I think it was Rothery, probably printed a lot of the stuff out for you. But the fact is, in a given chapter, you had to memorize multiple definitions and pages and pages and pages of notes. You probably can boil down all of my notes for this chapter into a page and a half. Because what you spend most of your time doing were problems like these, which you don't study for. Nobody's going to study this. So it's about a page and a half of actual notes. But the multiple choice is going to come from that. Like on the properties of the bonds and the polar, non-polar, and ionic bonds. I gave you some of those properties. Matter of fact, I put a matching section with 6 questions on it. It's going to simply say A, ionic, or B, non-polar, and it's going to ask you, somewhere down below, it's going to have some of the properties of them. Okay, so you have to look over those notes on that. The other place you'll need the notes is towards the bottom there. I've got 2 short answer questions. I can read them off to you, okay? Because they're not going to be exactly the same for everybody, but it's going to be one of the 3 intermolecular forces and one of the 3 metallic bonds. So this one says, explain in as much detail as given in class London dispersion forces. But it could say for your paper, what? Dipole, or hydrogen bonding. And for your a different paper on the metallic property one, this one says malleability, but it could say luster or conductivity. Okay, so and you're going to have to answer those in short answer, full, complete sentences and as much detail as you saw in the movie and that I gave you in class. All right. And again, if you didn't see any of that stuff, everything's online, like that you would need for. So you should have watched it by now if you've been absent. And there's this class, the other class is actually worse for absences, despite the fact that we had 2 people who were absent long periods of time. The other class with the mathletic stuff, there's like absent and late twice a week. Somebody comes in late or absent from that class. So that's why it's there. I mean, you can see exactly what you missed by looking at those up. So hopefully you do. All right, that's basically it. On the back is where you're going to put these. That's what I'm going to go over right now. And that's why the back is blank. And if at the end of this period you don't know how to do these, you got to ask yourself a question, why? All right? I probably will have done, by the time I do these 5 up here, close to 50 electron dot Lewis structure notations. Because if you think about it, I did about 10 in your notes. We did 10 on that worksheet. We did about 10 in the 2 lab periods. You did about 10 in your homework. And I'm going to do 5 more here. So that's 45 of these we'll have done. Okay, so I don't expect that anyone, after they leave here, has to study this. I'm not lying to you. I'm not saying you should go home and study this or practice this. You should get these right for the most part. What little mistakes you make, I'm going to correct right now. All right, so let's do this. Let's start with CA and O. Difference between the Marvins, what'd you get? 1.98. 1.98. If that's correct, then that makes him ionic. Everybody agree? Right? Is it 1.98, by the way? Some people don't seem to agree with that. 2 point what? Okay. Sounds like more people said 2.35. Well, I mean, it would be a point off because Marvin can't subtract 2 numbers. But that's not exactly the most important thing. He would have gotten lucky in this case because 1.98 is still above what? 1.7. Yeah, so that's the cutoff points. They're right over here. 0 to 0.4, 0.4 to 1.7, 1.7 above. They were not going to be on the board tomorrow, but that's what the cutoff points are. And he would have gotten lucky there because if he didn't get lucky and then looked that one up wrong and then did this whole thing as a non-polar or polar, I can't just take off 1 point for subtraction. All right. I mean, because I'm trying to grade you on how well you draw an ionic bond, and I may only have one on the test. So if you decide, oh, I'm going to make everything covalent, that's not fair. You're going to lose more than 1 point. But hopefully you can subtract 2 numbers. Ionic means one guy's losing and one guy's gaining electrons, right? So I write down calcium by himself. He's got how many dots in his outer shell? How many electrons? 2. And I write down oxygen by himself, and he's got how many dots? 6. Because he's in group 6. That's how you know it. And it's not like I've just done this chapter. I've been preparing you for this for 2 chapters already before this. Now, you ask yourself a question. A lot of people get this wrong. Or at least they got it wrong when I first asked this question on a lab, and then I saw it again on a worksheet. People want to put 2 oxygens around calcium because calcium wants to lose 2 electrons. But you've got to ask. Oxygen wants 2. Calcium has 2 to give up. They're quite happy together, right? All I need is 1 calcium losing those 2 electrons to an oxygen who gains them. And he gets a +2 because he lost 2 electrons. He gets a -2 because he gained 2 electrons, right? That's all I need to do. Notice how I drew it. All the electrons are around the oxygen. None of them are around the calcium. You cannot draw these halfway between. Secondly, I saw someone, I don't know if it was this class, their class, but he did this over and over again. That's wrong. A dash indicates a what? A shared pair. You can't do that. You cannot have dashes to indicate a shared pair of electrons for an ionic bond. All right, so anybody have a problem with that first one? +2, -2, make sure you do all that stuff, you're good. All right, now let's do the next one. I got room to do that without erasing everything yet. All right, let's do this one. S and BR. I draw, first of all, what's the difference between those here, Zach?
0.36.
So 0.36 is less than 0.4, which makes him non-polar covalent. So I draw my, and that means they're going to share. I draw my sulfur. He has 6 dots. I draw my oxygen. I'm sorry, bromine. I draw my bromine. He's in group 7. He has 7 dots. That's pretty, I guess I probably should have used a different guy here. They're kind of running into each other. I'll move it down a little further. All right, so I draw my sulfur with his 6 dots. I draw my bromine with his 7 dots. And then I ask myself a question. What does each guy want to make him happy? He would like 2 more. He would like 1 more. So he's got 1 to share. He's got 2 places to share. If you think of it as a puzzle, if I put 1 bromine here, 1 bromine there, that will take care of everything, right? So I need how many bromines to make everybody happy? 2. And I have to write that 2 in there because I can't create or destroy atoms or electrons. So and by the way, I don't care if you do this. If you do it like this, that's fine. Some people like to think of that, well, here's a space here and there's a space there. Remember, it's not really true. Once you start to share electrons, it's not like there's a left side and a right side to the electron dot notation. Okay? So you could draw it like that, but it would also be correct to do this. Okay? So in other words, you could draw it like that as well. All right? All right. Do I need arrows for this guy to show which way the electron? No, because he is nonpolar, we're assuming there's no real pull harder than the other way. Okay. There are some mistakes I do see on these kind of guys. For example, could you do this? Oops.
No.
Yeah, I can't do that. And I made this clear in the notes and on the labs when we did them, and when I corrected the homework, I took off for it. This is showing that bromine sharing with bromine, and he's not. This bromine sharing with a sulfur, and the other bromine sharing with sulfur as well. So you had to have drawn it with the bromine. I don't care where they went around. They could have gone here and here, or here and here, or here and there. I don't care where the 2 of them go, but they can't be bromine next to bromine. That's implying something that didn't happen. All right, let's look at water. Water, I think, is 1.17, if I'm not mistaken, right? Which makes him polar covalent. Everybody go with that? All right, so we draw H by himself, and we draw O by himself. And we all know how many dots he goes there. For the last 2 chapters, we've been doing that. To make everybody happy, what will I need this time? I'm going to need 2 hydrogens because I've got to share electrons here and here to give him an octet. And although hydrogen will never have an octet, and I hate when people do this as a final answer. You'll see it in a second. I want to draw it correctly first, though. So I put my two hydrogens around here, and again, it's fine if you do this. That's fine. Or you could have had them all on one line. That's fine, too. I wouldn't care about it either way. All right? And I do want you to tell me which way they're pulling. So we would have electrons pulling that way and that way. What I do not like, what I absolutely hate, that, by the way, would be the correct answer. Anybody have a problem with that? Everybody okay with that? I hate this. People just love throwing dots around hydrogen. Okay, out of nowhere, they're just going to make them all have dots around them. Okay, he wants to be like helium. He doesn't want to be like neon. He just wants to get one more electron so he can be like him. What do you need?
Do the hydrogen peroxide and potassium iodide.
Yeah, the potassium iodide maybe. I used is that for the oxygen generation? I use manganese dioxide for that. And that's in there. Those in there on the bottom shelf to the left, and the hydrogen peroxide also. Yep. Not that one. The next one down. Put these on the cart. You can just take the cart down.
I'm not sure about it.
If you want some wooden splints too, they're in that cabinet with the owl to the left.
I have splints. How much of this do you have used?
I just put a little. All I need is a little tip of the spatulas in there, yeah.
Enough?
And you got the hydrogen peroxide.
Hydrogen peroxide.
All right. Okay. So that's water. No problems with water. I'll go with that. All right. Next. P and Cl. What's the difference between those two guys there? When you subtract the two, Maddie. She got 0.96. If that's correct, that makes him polar covalent as well. I draw P by himself. He's in group 5, so he has 5 dots, 5 outer shell electrons. I draw Cl. He looks like this. He's in group 7. He's got 7 dots, 7 outer shell electrons. He wants 1 more. Phosphorus wants 3 more. In order for them both to be happy, they're going to have to share. How many of each will I need, Ronnie?
You need 2 of, no, 3 of the Cl.
Right, I'll need 3 Cls. I'll need 1 here, 1 there, 1 there. And I don't really care if they go in those exact spots, but that's fine if you do that. Cl, Cl, and Cl. Now, while I've got another polar covalent one, let me say a few things also about the difference between these guys and ionic. Notice I'm sharing the electrons, so I'm writing them halfway between. You would not have done that with the calcium and the oxygen. All the electrons are around the oxygen. Secondly, I'm pulling electrons, spending more time around one guy than the other. Who's pulling harder in this case? It's not always the guy in the middle. I think people tend to do that. You have to look it up. Who's got the higher number? Cl. So it's going this way. Got it? People tend to, oh, well, geez. And all the other ones we did, it was pointing towards the middle, so it must be pointing towards the middle. And they don't even think about it. Look, it's you know what this is. I use a tug of war as an analogy for this. Chlorine's pulling harder than phosphorus, okay? So he's going to pull his electrons closer to him. So there, that would be your final answer for that guy. Got it? And again, this would be wrong. That would be wrong. You can't just do that. That doesn't look like you're sharing electrons to chlorines in here. No, you're not doing that. All right, last one, and this is one that illustrates one of the tougher parts. We saw only a couple of places where this happens. We'll see a little bit more in Chem 2, but not much. Electron dot notations, I mean, they can get really complicated. When you go off to college, if you take a chemistry class in college, I'm just doing some very, very basic ones, giving you the basics of it. You can get ones that get kind of hairy. You know, we have other things we have to do as well. Obviously, the difference here is 0. Between oxygen and oxygen, you have no difference. And that makes them non-polar covalent. Now, when I go to draw my oxygen, I'll draw them up here. And my other oxygen. Okay? The most common mistake you see here is this one. And I'll draw it for you first. Okay, give everybody an octet. Everybody's happy. Can't do that. All right, because I just created electrons out of nowhere. I got 6 here and 6 here. That's 12. But I've got 2, 4, 6, 8, 10, 12, 14 there. Well, I can't just erase 2 electrons either. Why not?
Yeah, not that.
Yeah, they don't want to have an octet. But I can solve both problems if I do this. If I have a shared pair of electrons. Okay? 2 pair of electrons it is. And it will look like that. Oh, and by the way, I also mentioned, and I didn't draw them all this way, and it's okay if you don't, but you could draw dashes for a shared pair of electrons like that. You could have done it for the PCl. You could have done it for the H and O. You could not have done it for the Ca and O. Why? He's ionic. You're not sharing electrons. Okay, but you could have done this. So this would be correct. Either way, you want to write that. Now, before I leave it, that's the last of the. Any questions, first of all, on these? That's going to be a major part of the test.
I have a question. So when you have H2O, the 2 is telling you that you need 2 hydrogen.
Well, the 2 isn't telling you that. You're telling yourself that. All right? You're not. I'm not going to tell you that it has 2. When you have an H and you have an O, here's what you don't. That's why I'm trying to get it across to you. You have to decide how many of each you needed. For this guy, you needed 3 Cls and 1 P. For this guy, you need 2 H's and 1 O. For here, you needed 2 Brs and 1 S. And here, you need 1 to 1. The way you know is that everybody wants to get an octet. He needs how many? He needs 1 here and 1 there. And he can only provide 1. So if I put 1 H there, I need another H here. And all that has to be in my head. I'm not going to tell you to put 2 there. You have to tell yourself, geez, I need 2 in order to make everybody happy. That's what you have to decide. So let's make one up. Let's say I have Al and Cl. And let's say it's going to be an ionic bond. Here's Al. Here's Cl. Oops. What will I need? How many of each will I need, Maddie? If he wants to lose and he wants to gain. Okay?
That's not what I meant.
Either way, whether it is what you meant, if you can't answer this question, then you're in just as bad a shape.
3 and then
3 what? 3 aluminums? Absolutely wrong. See, this is something you need. You need it even if you weren't asking it. Because the question you asked, even if I didn't understand it, I know it implied that you didn't understand it. Because, anyway, let's just finish up. I do not need 3 aluminums. Aluminum wants to lose 3 electrons.
oh,
So, what will I need? In order to make everybody, in order for him to lose 3, what can chlorine do? What does chlorine want?
he wants 1.
He wants to gain 1. So what will I need to make both of them happy?
Need 3.
I'll need 3 chlorines. 1 for that guy, 1 for another chlorine, and I would have to write him with the chlorine here, and a chlorine, assuming it's ionic, all right, with all the electrons around him. All right, and none of them around him. He'd have a +3, he'd have a -1. So the reason that your question, I could tell, was not correct is you were saying, so the 2 tells you to do this. No, you tell me how many of each you need. Now, what else did you not understand about it? Go
When
ahead.
you write H2O,
When I write H2O?
to
Okay.
their, like,
It's because you have to be used to it. Yes.
right, that's how I was wondering.
Well, but it's a good thing I corrected that because you had the other ones. Yeah.
Because in the book, when they had the problems, they had like the little subscript thing.
Well, yeah, but I'm not doing that. And when I did it in the worksheet I gave you and in both labs I gave you, I did not tell you how many of each. You're right. I could tell you that the formula for say for example calcium fluoride is CaF2. I could say that, but I'm not going to. I'm going to just say, what would I get if I put Ca and F together? That's how I'm going to ask the question, and you have to decide. Well, geez, I'm going to need 2 Fs because calcium has 2 electrons to lose. Okay, so that's what you're right. Some of the book questions, but only a few of them. I gave you most of the ones I did. I only did something like this: Ca and F. All right. Any other questions on these before I talk just a second about this? That's all I want to say about these is these are the ones obviously worth the most points in an individual question. They're going to be short answer questions. Answer them in complete sentences and with as much detail as I gave you in class.